In this video, we're going to draw and name some hydrocarbon structures on pages 11 and possibly page 12 of your homework packet. So let's grab a document and take a look. Okay, I'm going to go to page 11, and I think it's, let's see, it's probably letter E. And you're asked, you have this structure here, you have a little marker here, and you are asked to name this structure. Okay, so it looks like we have what one is kind of numbered here. So we got 8 carbons going here, 2 more carbons here. Looks like we have an iodine right here, or an iodide right there. And remember, at the end of every stick that's pointing out is a hydrogen. It's a carbon-hydrogen bond when we're doing hydrocarbons. So let's look at our naming rules and come up with a name for this. The first rule is count the carbons in the longest chain to get the root name, and then check for single, double, triple bonds or H group and use the appropriate suffix. And I'm going to give you a hint. We are going to have single bonds for this first one, so it is going to have the ane ending. All single bonds have an ane ending. When you get in double bond, you get an ene ending, a triple bond, an ine ending, and an alcohol group, you get an OH ending. So let's go back and we'll do the name here. So I believe we have the longest chain is 8 carbons in a row. And I'm looking at an 8 carbon chain as an oct. If there ain't any double or triple bonds, it's an ane. So we should have an octane for what we are drawing right here. Notice our longest chain is 8. Okay, so 8 is the longest chain. So I'm going to put the last name first. I'm going to call this an octane, and I might just write it like this right here. Now we're going to have some prefixes to talk about the 2 branches that we have. So we have a branch here on number 3, and we have a 2 carbon branch going in the same direction right here. Now notice I'm supposed to number carbons. If there's no double or triple bonds, I number carbons at the end nearest the closest branch. And notice if I started from left to right, or it might look backwards as I do this as a screen image. I can't remember how that's going to look, but this is going to 1, 2, 3, 4. We'd be on the 4th carbon right here. Going from this direction, the I is on the 3rd carbon. So going in this direction, the I is closer to this edge than the 2 carbon branch is closer to this edge over here. So I am going to number from 1 through 8 going this way. So let's look at the name of these branches. I have a 2 carbon branch, and then I have an I. All right, might just draw a little thing around this. This is the 2 carbon branch, and then this is the I. Right, and let's go back and look at our rules on the yellow sheet or on page 4 of your homework packet. And these are the name of some branches. Okay, a 2 carbons in a row off as a branch is an ethyl group. Okay, or a C2H5 would be an ethyl group. And then the I would be iodo, okay, from the base root iodine. So that's what I'm going to be using in my naming here. Notice when I draw this is that I have C1, 2, 2 C's and 1, 2, 3, 4, 5. This is the branch C2H5. So this is a methyl branch an ethyl branch, and it is on number 5. This is an iodo, and it's on number 3. Okay, the octane should go last. I'm not too concerned with the order you put these in. Technically, you'd alphabetize it, and so I'm going to do that and call this a 5-ethyl. And then I'm going to say it is a 3-iodo, and then octane. I had a lot of space skipped in here, but typically you just kind of run this whole thing together. So it's a 5-ethyl, 3-iodo octane. What if I had two iodide someplace? I'd call it a diiodo, but that's not the case. I have one iodo on number 3. I have one ethyl, which is a 2-carbon chain, on number 5, and there's no other branches. Okay, so it's important to put the octane part last, the 8-carbon chain, and it's all single bonds with the ane ending. If these two get flipped around and you call it a 3-iodo 5-ethyl, that's fine. But do number 8 carbon starting at the closest outer branch with the iodide right here on number 3. Okay, I'm going to do an example of drawing one. So I'm just going to try this one down here. And it says 2,4-dimethyl-4-heptane. So I'm going to go back to this thing and say heptane is a 7-carbon chain. And again, it's all single bond, so it's going to get an ane ending. So I'm going to do that first. All right, come back up here. And I'm going to call this last name A. Let's try this again. I'm going to call it Heptane. Okay, I'm sorry. I'm doing this backwards here. A heptane is a 7-carbon chain. Not really trying to name this when I'm looking at this. So 7-carbon chain is right there. So I'm going to actually draw that chain in here. And I think I'm not going to use the, yeah, I guess I can. I'm going to go to the text function and draw like this and do a dash and then a C and then a dash and then a C, 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 and then a dash and then a C, and then a dash and then a C, and then a dash. And it looks like I have 1, 2, 3, 4, 5, 6, 7 carbons. Okay, so that's what we want in our structure. Now we need a methyl on number 2 and a methyl on number 4 because we have 2 methyl groups. All right, so I'm going to do that. And I'm going to put a methyl. I'm going to go from left to right here. And I'm going to draw in a methyl on number 2, which is a C with 3 hydrogens. So methyl group is a C with 3 hydrogens. And I'm going to also do that on number 4. A C with 1, 2, 3 hydrogens. Okay, I'm just going to go back up here and check something so we kind of see what I'm getting at. Because a methyl group is a CH3 group, C with 3 hydrogens, and an ethyl group is a 2-carbon chain with 5 hydrogens. So going back, I think we're okay here. I have on carbon number 2, I have a CH3. On carbon number 4, I have a CH3. Okay, on carbon number 4, I also have an ethyl group. Okay, so I got to draw a 2-carbon chain here. I'm going to kind of extend this because I kind of am caught in the word here. So I'm going to do a 1-carbon here. I made that really long because kind of didn't plan my board here. And then I got to put a bond there and a bond there and a bond there and a bond there. And I hope you're going to be able to see the bond like right down here. Got one up right there. So this is C2H5. That's also on carbon number 4 right here. Now carbon always has 4 bonds. So when you do these, you always got to finish your sticks. So my battery's getting low and now I'm marking all over the place. Oh, that worked pretty good. Let's try this. 1. So we got 4 carbons there. Notice I already got 3. So I put a hydrogen there, a hydrogen there, a hydrogen there. Now this looks really bulky and it looks like these carbons are like across from each other, but they're really not because it spreads out in 109-degree angles. So it really zigzags a lot more and there's a little bit more room than we'd expect. So I go through and match up, and then I just make sure I got 4 bonds to all my carbons. So I got a heptane, 1, 2, 3, 4, 5, 6, 7, no double or triple bonds, so it's an ane. There's an ethyl group on number 4, which is a 2-carbon branch filled with its hydrogens. And then there's 2 methyls, one on number 2, one CH3 on number 2, and one another CH3 on number 4. All right, so this is naming a hydrocarbon, and then this is drawing a hydrocarbon based off an ane, following these rules that we have. Okay, so that covers it for page number 11. Those are a couple examples. Thanks for watching.